Good morning, internet people. How are we all today? Hope you're all well. Today I'd like to maybe talk about, I don't know quite how to frame this statement, but bear with me. There's a lot of this maker space things going on now, making your own furniture, making all sorts of tools and items, and there's some great channels on YouTube, don't get me wrong. I'm all for it, independence, self-reliance, developing your skills. It's all good, yeah. Well, it's not quite all good. With or through my exploration of YouTube, I've discovered a number of channels which deal with the remelting of HDPE plastic. Now, I prefer to work in steel or stainless, but I utilise all sorts of materials in both in my work and in my hobbies. Yeah, everything from hardwood to balsa wood, aluminium, brass, just whatever's necessary for the task. And I was thinking, some of the projects I saw guys making with HDPE, some of the boys were just kids. There was other guys there that were the creative types, doing fancy, colourful patterns and messing around. Your hipster fuckwits, basically. Well, power to them if that's what they want to do, yeah. But I've got a problem with it. Now, I thought it would be a useful material for the lathe. I could maybe melt down some milk jugs, compress it into some tin cans, cut the tin cans away, and I'd be left with some reasonably uniform bar stock, which I could turn down to make maybe bushes or bearings or that sort of thing. So I went out and obtained a cheap little portable oven and a few of the bits and bobs that you need to process the plastic. You've got to cut up a lot of milk bottles, believe you me. And I'll get on with my first attempt. I filled up a tin can. It was about the size of what would I call it? The little tins of sweet corn you get. You get the sort of big round ones or the wide ones, and then you got the narrow ones. Well, I used one of the narrow ones to begin with. Filled it up with plastic, and I got a bit of round wood to press into the tin, and I used a little wee hand clamp just to apply some pressure to it, and that was all I got out of it. Yeah. When you compress it, it squashes right down, so the full tin ends up just this little piddly bit at the bottom. Now this is my first attempt, okay? You can see that I wouldn't call it porosity because there's more air in it than there is material, but while the material has fused or bonded together, if I were to try and bend that with two hands, you'll hear it cracking. When I press on it, although it's quite firm, there is a little bit of give, which gives you an indication of how hollow it is inside. Weight wise, it's quite light, yeah. And you can see from the surface finish that it's not bonded very well, you know. I don't think this would be useful for anything. If I turn that down, there's going to be nothing but voids. You know, it might come in handy as a doorstop. You know, I could maybe cut that at a better angle and make it into a doorstop or something. You know, it's not going to be used for much. Now, I only let that heat for maybe 10 to 15 minutes. I maybe didn't leave it long enough, yeah. So I took this result and I worked on it. And one of the problems I was having is I was struggling to get a pressure on the bit of wood down inside the can, because obviously the wood sunk into the can quite a considerable distance, and then I was struggling to get a reach with the jacking screw from the hand clamp. So I thought, well, I'll make some more discs of wood as a spacer so I can carry on applying pressure. But so I did that, and I thought I'd have a second go. Now, one of the things that I took from the first attempt is that it hadn't bonded very well. I maybe didn't have enough pressure, and I maybe hadn't heated it long enough. So with that in mind, my second attempt, I heated the plastic longer. I heated it repeatedly, and each time I compressed it, I would add more plastic on top, and then heat it again before pressing it again. And I did that for a period of about an hour. Okay, so multiple heat treats, if you want to call it that, with multiple additions of extra material, and this is what I've got. Okay, again, you've got voids, a large void there. I don't know if that's maybe air that was trapped, because obviously the compression was the extra compression. I had extra compression under this one because I used a little wee homemade press with a jacking screw, which I could really nip up tight. So I was putting a lot more pressure on this than I was on the previous one. However, I still get voids. Yeah. So on the base here, though, you can see that the base has turned out remarkably well. There's just one tiny little void there, and maybe a few other little wee specks here and there, but generally it's very solid. And you've got quite a nice marble effect as well. I'm assuming that's just from the plastic burning somewhat a little bit, but it really does look like a marble. So I was more pleased with this. Okay, more pleased, is that really proper English? More satisfied, perhaps. But I have misgivings about the whole method. Folks, it doesn't matter how careful you are, you're going to release fumes into your airspace. Now, you can do it outside or in the garage, but you'll still be releasing nasty fumes. Not only that, to melt the plastic, you're going to require energy, and you're going to be heating up plastic bottles or plastic caps, whatever it is, to make your little project. Okay. Now, if you're looking for that multicoloured sort of marble effect, maybe you can't buy that in the shops. You know, I've seen one guy using strips, so blue and yellow, and he must have had a reason for that. I'm not interested in the colours, I'm just wanting material for bearings, yeah. And I've done a price check, and this stuff is actually more expensive than I would have assumed it to be. For a 2 metre length, you're looking at about £100. So, working it out, 1 metre would be 50 quid. 100 or 10 centimetres would be a fiver, yeah. And that's at 70mm diameter, which this here is roughly. That's actually 75? No, it's actually 70, yeah. You can see that's 70. Yeah, okay. And you've got a rough height of, let's just do it in the middle here, so because it's a bit slanted, and you've got about 70mm in height there. So a little bit taller, like maybe the full height of a bean tack can, is £5 from your supplier. Now there might be postage charges on top of that, you know, depending on your area. That can be quite a significant addition to the cost of this material. But generally, if you go to businesses that are maybe have need of this material, you know, companies do buy this stuff in, and or they can certainly place an order for you, and then it gets delivered to their business address with their next order, and they'll be quite happy. They'll sell you a bit. A lot of companies are, anyway. So my point is, I don't think you can really compete with the efficiencies of scale when you're making this at home compared to buying it online from an industrial supplier. Not only can you not compete with the cost, you're going to find it very difficult to have or to reach the quality of the material that you can buy. All these voids, that makes it practically unusable for me. Yes, maybe I could, you know, this is only my second attempt. I could try different techniques, or maybe try different equipment. And you know, I'm sure if I put a bit more effort and time and thought into it, I could improve upon this. You know, some sort of extrusion system, you know, motor driven with a heating element possibly. Instead of having a jacking screw, I could maybe have some hydraulic arrangement to compress the molten material. There's all sorts of methods and ideas out there, but that's all extra cost, and is it worth it? Really? You know, for the time and energy, and you know, I would say there's a bit of risk to your health here with this stuff as well. HDPE may be a non-toxic in its sort of solid state, but when you melt it, it's like any other plastic. It's going to give off chemical fumes, and that cannot be good for you. Especially if you're doing it regularly. I don't think, you know, if you tried it once, it's going to have a big impact on your health. But it's just an unpleasant smell. You know, you do get an unpleasant smell from when this is melted. So I don't really think it's worth it. You know, so end off. And I'm cheap. If I can save a pound, I will. You know, I don't spend money on this. I absolutely have to. So that's my tuppence worth on this whole HDPE malarkey on the YouTube now. I think you're wasting your time, folks. I really do. You know, you'd be better utilised going and getting a job, or doing some sort of work that makes you some money. You know, maybe if you're a creative type and doing all this colourful marble little things that you do, how much are you actually getting for those projects? $5 or £5 maybe. Nobody's going to pay you more than that. That's, and you're putting in hours and hours and hours of work into it. So, but if it's a hobby, fine, just carry on, But I suppose that's my tuppence worth. I want to say I'm disappointed, a little bit disappointed, I suppose. I was hoping to get a more solid material than what I've got here. There's just too many voids. I was thinking of maybe making up a couple of molds, just sort of basic rectangular or cubic type molds where I could get like sort of solid blocks of the plastic out, and then machine that down into maybe soft jars for the vise, or I don't know what else I could use it for. Maybe some sort of PTFE like bearing surface. That this stuff seems to be fairly resilient, resistant to abrasion, and it's quite slidey. So I was thinking it's maybe got similar properties to PTFE, which is quite a slippery, low resistance plastic, good for bearings and bearing surfaces. But with all these voids, that's just going to pick up dirt and then cause wear on any material that's sliding up on it. So no, it's a fail. Pity. But that's I think about all for now, folks. I'm going to crack on with my other little projects in the meantime. I did my first aluminium melt the other day, and that didn't go very well either. I wasn't expecting it to be honest. The crucible was just a little wee pot for holding kitchen utensils, so you can imagine that the wall thickness of that pot was very thin, and it did indeed fail as suspected. So I lost all the most of the aluminium onto the ground. But the fact that I was able to melt the aluminium in the first place using just a steel pail and some charcoal briquettes was actually quite surprising. I didn't think I'd get enough heat there to do it, but it worked surprisingly well. I'd gotten maybe half a pint of aluminium, or maybe a pint of aluminium within the hour, just from melting aluminium cans. So if I use a propane furnace and a larger crucible, I could be making a significant amount of aluminium out of that for little projects. But that's another video. Thanks for watching. Stay safe, don't put your health at risk, and catch you next time. Bye for now.